All right, so is it recording? Yeah. Okay, so the third question we have here is determining V1, which I haven't labeled yet. It's going to be this spot over here. So V1 is pretty straightforward to get, well, for me, but if you don't have much experience with this, it's going to be a bit tougher. Let's look at the information that we know so far. So we're gonna write all of that down. Usually these questions are listed in a way such that part A is going to help you with part B and part B is going to help you with part C. So from part A, what we found out was that the IT, the total current, so that's the current leaving the battery, was equal to 1 amp. It was about 1 amp. From the second part of the question, what we found out was that the current moving through this branch over here, let's just call that I1. Let's just say it. So I1 was equal to 0.5 amps. And we found out the current moving through here, let's just call that I2. So I2 was equal to 0.3 amps. 0.3 repeating. So a different way to write that might be 0.33 or just 1/3 amps. Okay. So now we need to find out what the voltage is at this point over here, at this little tip. So before we do that, it's always a good idea to kind of understand what we're finding the voltage of. So this tip over here is actually a node, and that node, let me see if I can extend it a little bit. So that node, solid fill, that's going to be white. This node over here, we can actually extend it all the way to here. Remember in the other videos I've mentioned that you can always extend a node as long as there's no resistor or capacitor or battery or something else in the way. As long as it's a wire, you can always extend the node and say, okay, this big white thing is just one node. So we're trying to find the voltage of this node, which means we need to find out what the voltage of an electron is going to be when it gets to this point over here. Because this point over there is the same as this point over here, same as this point over here, because it's all one node. So, okay, oh no, all right, one sec. There we go, delete that. Okay, so this is pretty straightforward to do because we have this current that's going down this way, and we know the current and we know the resistance values of these resistors, so we can find out how much voltage we've lost. So starting from the beginning, let's move this stuff over. So we had 1 amp leaving the battery, and the voltage here is 30 volts. So in a way, you can think of it like an amp is it's the rates of electrons moving, right? So 1 amp is a lot of electrons moving, right? It's enough to kill you very easily. If you had like 0.1 amps, then you'd have 10 times less electrons moving. The voltage tells you about the energy of the electrons. So let's see. So these electrons all have 30 volts of energy. Now they're traveling along this wire. Oops. Let's delete that again. So they're traveling along this wire here. Travel. And they hit this blue node over here. This is one node because remember there's nothing in between them, so you can extend that node. I'm just gonna get rid of that. So they're traveling along here. They hit this node. Some of the electrons go down here, some of them go down here, and some of them go down this way. So the ones that go down this way are the ones we're interested in, and you'll see why in a sec. So before they go down any resistor, these electrons still have 30 volts of energy. And then they have to go through this resistor. So how much voltage are we going to lose when the electrons go through that resistor? Well, we just use voltage drop across a resistor is equal to the current moving through the resistor multiplied by the resistance of that resistor. So the current moving this way, based off what we got from question B, is I1, and I1 is 0.5 amps, right? Remember 0.3 go down this way, some other amount goes down this way, and 0.5 goes down this way. So that's going to be 0.5, let's write our units, multiplied by the resistance, which is just 8 ohms. And so what we're going to have is a voltage drop of 4 volts. Okay, so we're going to lose 4 volts here. So what that means is that by the time the electrons get to this point over here, their voltage is only going to be 26 volts because they lost 4. Okay, so the electrons travel. Remember, they don't travel this way because there's no resistance down this path, so they'd rather travel down this path. Okay, they're traveling. Then they hit this resistor over here. How much voltage do they lose here? Well, voltage drop is equal to the current moving through the resistor multiplied by the resistance of the resistor. The current is still 0.5 amps, right? Because the only time your current decreases is if you have like a branching point. So if you had like 0.5 amps up here, and then you had like a branching point like this, where you had 2 resistors, some current would go down this way and some current would go down that way. Now, if you had a branching point where you only had one resistor and the other one was just a wire, then all of that current, all 0.5 amps, would move down the wire because they don't want to go through the resistance path. Okay, so just a refresher. So it's 0.5 amps, and the resistance that they're going to go through over here is 12 ohms. So that's 12 ohms, and so that's going to be 6 volts. So over here we lost 4 volts, over here we're going to lose 6 volts, and so the electron that comes over here is going to have 20 volts, right? It lost 4 here, it lost 6 there, so 30 minus 6 minus 4, that's equal to 20 volts. So the voltage at V1, the voltage of electrons at V1 is going to be 20 volts.